Einstein's general theory of relativity tells us that anything that wants to move at superluminal speeds or faster than light speeds requires an infinite amount of energy to do so. But there are loopholes to this rule. One example is that two patches of space-time relative to each other can move at superluminal speeds. One example of that is that anything in the unobservable universe relative to us is going faster than the speed of light, and we cannot observe it. And Miguel Alcubierre notices this and manages to make his Alcubierre drive. This drive has you in a little bubble or patch of space-time which can move while you seem yourself basically stagnant. But actually, you're moving at superluminal speeds compared to everything else. This is by contracting the space in front of you, but expanding it behind. Well, what's the issue with this drive? One main issue is the fact that this drive requires more energy than that of all of the observable universe, which is relatively hard to come by. This is what gives it the property of having negative energy density, which for our purposes just means that it's impossible. And ignoring the properties of the fact that it messes with time and going faster than light, there's also the fact you can't steer these from within the bubble. This is what leads to inventions on this drive like the Khrushchev tube, which uses this drive to make sort of like a conveyor belt all the way at the speed of light to your destination, but you can't get off it and have to go all the way back. But do not fret, my spacefaring friends, there is a positive solution to this problem. Eric Lenitz and his Breaking the Warp Barrier does have a positive solution to this issue. In his paper, he describes how you would distribute some energy, let's say plasma, around the spacecraft in some extreme densities and temperatures, which would then contract and expand space-time around it, making a bubble which can move at superluminal travel. And although this is a positive solution, there are some caveats that comes with it. One main issue is the fact to even hold a moderately sized spacecraft, some of the energy densities in the strips requires more mass than the resting mass of a tenth of our sun. And it's hard to imagine how such thin strips would not just collapse into a black hole. And with all of these space bubbles to be able to move at faster than light travel, they're all inertial in nature. This means that they have to start at superluminal speeds to be able to stay at superluminal speeds. And we don't even know how to get there yet. So for now, we're gonna be stuck at our subluminal speeds. But it doesn't always have to be like that. You never know. Maybe one day we'll be breaking Einstein's speed limit just as often as we do the speed limit on the freeways. Just try not to be caught by the cosmic police.